So, hello everyone. Today we are going to discuss about the concept of RAG. So, what actually the RAG is? RAG means Retrieval Augmented Generation. Before discussing the concept of RAG, we will understand the concept of the large language models. What are large language models? These large language models are nothing but deep learning models which are trained on the entire internet data set. Now, these large language models have two powers. First is their reasoning ability like human, and second is their information power. Okay. Now, what are the limitations of LLM? So there are basically three limitations of LLM. First is knowledge cutoff. Second is hallucinations, and third is one is lack of specialization. This lack of specialization limitation uh, g- uh, gave birth to the concept of RAG. So now, what actually this limitation is? Let us understand this by an example. Suppose we ask any LLM like a question like who is the president of India? It will give us expected answer. But if we ask from the LLM who is like yeah like what is the salary policy of this xyz company, it will not be able to give us expected answer because it the LLM is trained on the entire general data set. It does not have personal information. So we thought of connecting the large language model with our personal data so that LLM can give answer based on this personal data also. So this is the basic overview of the RAG, like connecting personal data to the large language model. Okay. Now, this was the basic overview of the RAG. Now, we will understand the architecture and engineering of the RAG. So, there are some core concepts of the RAG. First is vector embeddings. So, now what actually happens? We have a personal data in a document. We convert each word of that document into vectors such that similar words are close to each other in a vector form and not similar words are not close to each other in vector form. Like king and queen will be very close to each other and king and technology will not be close to each other. This is the meaning of semantic mapping and unified space. Okay, this converted vector of word are stored into vector database. This is the backbone of retrieval. Now what actually happens? Now we have a word vectors in the vector database. The user asks the question. That question is converted into vector form. That converted vector form question is sent to the vector database. Now using cosine dot product, we get some relevant or similar using cosine dot product vectors from that vector database. Now we have two things: our question in vector form and the some documents in vector form. We convert those into text form. Now we have two things. First is question and second is relevant docs. The relevant docs are sorted in such a way the document which is very much similar to the question, which is very much relevant to the question, is in the first, second, third, and like this. Yeah, then we send this question along with relevant docs to the LLM and we get our expected response. These are the applications of the RAG: smart customer support, personalized content creation, advanced research assistant, domain specific chatbots. Now, this is summary why RAG matters. It overcomes LLM gaps, it is cost effective, it is transparent, it is smarter AI. So, yeah, we have discussed the theory part of RAG. Now, we will discuss the practical part of the RAG. So, first of all, we will activate our secret variables. We will import our large language model along with embedding models. We will import our GPT 3.5 Turbo. Our this will be our LLM model, and this model for embedding model. Okay. Now we will see that our LLM is working fine or not. This is used for breaking our text into components so that each so that component by component we send to vector database in vector form. Okay, this is our vector database Chroma. This is for loading our PDF. uh, this will be the PDF which we'll be using for our RAG. This is a vector database files. By these two line of code, we are loading our PDF into our system. We are breaking that PDF into components by using this two line of code. We are converting that PDF into vector form and that storing that vectors into vector database using this line of code. Yeah, we are creating our prompt. Okay, so now we are designing our architecture. First of all, in the rack chain there will be prompt. That prompt will be having the question along with relevant documents. That prompt containing the question and the relevant documents will be sent to the large language model, and we will get our expected response. But this response may contain some meta information or irrelevant information. This will be filtered by using the string output parser. And finally we have our basic final response. So now here we will take input question from the user. We will get the relevant docs from the vector database. We will send both question along with documents to the LLM, then we will get the response. This is how our RAG works.